Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is restore the array from adjacent pairs. So there is an integer array nums that consists of n unique elements, but you have forgotten it. Okay. However, you do remember every pair of adjacent element in nums. So you are given a 2D integer array adjacent pairs, which will be representing pair in the form of u comma v, which indicates that u and v elements are adjacent in nums that you have forgotten. Okay, it is guaranteed that every pair of adjacent elements will be there in the adjacent pairs array, and adjacent pairs array will be having a size of n minus 1. Okay, so if let's say you consider array to be 1 2 3 4, and this array is of size 4, as you can see. And if you go on forming the adjacent pairs, then you can form only 3 adjacent pairs. So if there are no adjacent pairs repeated, then if let's say size is n, then n minus 1 pairs will be there. Okay, this is our observation. So this adjacent pairs array will be, if you form a graph of this particular adjacent pairs array. For example, if this adjacent pairs array is given to you, now 2 is having its neighbor 1, 1 is not having any another neighbor, 3 is having 2 is having another neighbor which is 3, 3 is having another neighbor which is 4. Okay, so the graph will be something like this. This will be your graph. This is your adjacent pairs array. It will be given to you, and you will be forming a graph out of this. Okay, so in this particular problem, our objective is to find either of these two ends which are not having both of uh, their adjacents on the both sides. Since if the array is like, let's say 1 2 3 4, then you can see this one is not having any left adjacent, no left adjacent. And similarly, if you go on for 4, then it is no having no right adjacent. Then if you can find any of these, what you can do is you can simply do a DFS, depth first search, and you can go in this direction, and then you will be having your array 1 2 3 4. Or it is mentioned in the problem statement that the pairs that are given to you can be in left to right or right to left direction. What I mean by this is, if let's say the original array is something like this, then the, let's say this pair is given to you, then it can be given in the form of 3 comma 4, or it can be given in the form of 4 comma 3. These two directions, any of these can be given to you. So it will not matter much that if you are starting from 1 or 4. If you are starting from 4 also, then it will be a valid answer. Okay, so it is mentioned also that return the original number if there are multiple solutions, return any of them. Okay, so the whole problem boils down to finding the edge of the array. These I'm calling this these are the edges of the array. Okay, edges or extremes. We have to find them and then simply run a DFS. You will get your original array. To find the edges is another problem or extremes. For that, what you can do is you can be using a breadth first search approach. You may pick any of the vertex in the graph. Let's say we pick 2. Then you will explore the neighbors of 2. And if they are not visited priorly, then you will enqueue it to your queue and you will keep exploring. And then you will keep track of your explored vertices. And then you will see what was the last vertex that was explored. Last vertex explored in graph while doing BFS, which is a breadth first search. Okay. So those of you who are new to DFS and BFS, these are graph traversal techniques. And if you are not familiar with them, I will be providing links of article describing them. And you can check out those articles and then you will be able to understand what we are talking about here. Then once you are having your edge or extremes, one of the edges or extremes, then you can simply run a DFS. Okay, and your array will be reconstructed. So let's have a look at the approach. So first of all, you will do the graph construction. Let me quickly zoom in so that larger portion of code is visible. Code is more visible to you, not larger portion. So first of all, we will be making graph from the given adjacent pairs. So I have, for my convenience, I have taken the adjacent pair names as ADJ. Okay. So if you want, you can replace it with adjacent pairs. Okay. So graph construction from adjacent pairs. And then we will be populating our graph. Okay. Then we will separate out the vertices, which are here, as you can see, u comma v. So then we will connect those vertices using adjacent pairs. Okay. Then to find out the vertex on the either side of the given graph, or say that is representing an array, you will be doing a BFS. Okay. And this is just a standard BFS with some little tweaks. Okay, this is just a printing statement that I used for debugging. And you will keep track of your last vertex visited. Keep track of last vertex visited, as it will be representing one of your extremes of the array once you are done with BFS. Okay, so now you are having one of the extremes of the array, then you can easily run a DFS to deconstruct the array. We will be constructing the original array by running a DFS on graph starting from one of the extremes of the array. So extremes, again I will tell you, extremes are either leftmost element or rightmost element. Okay, these are extremes or edges, you can say, of the given array. So this will be your original array that will be reconstructed, and after running a DFS you will just return the original array. This is just a DFS approach here. Okay, DFS. Okay, so let's try to submit for sample test cases. As you can see, it's getting accepted for sample test cases. Let's try to submit for final evaluation. As you can see, it's getting accepted for final evaluation also. So if you are having any doubts or any queries in general, please feel free to ask them in the comment section. I will be happy to answer them. Thank you for watching. Have a great day ahead.